What's up, what's up? Welcome back. Today we're working on my image to ASCII or image to UTF-8 neural network. So the idea of the project, we have image on the left, we want to get text on the right. We look at this image on the right and we like zoom in and we go, oh, these are actually made up of like a bunch of different UTF-8 characters. And the goal is to get like a reasonable output on the right with maybe like some form of like subglyph accuracy, right? So you can imagine that like you have like an image here, you take a sample and you have something in there that looks kind of like an X. You kind of hope that the character X comes out of that, right? Or if you have like an image that's like super dark on one side and super light on the other, hopefully there's like some character that approximates that. And you can do better than if you were to just like say, pick like the brightness for each glyph and try to compare, right? This is what we get if we do brightness only. But if we try to do something a little more intelligent, we get something like this. Great. And what we were working on a couple streams ago is we found out that the distribution of like brightnesses of or brightni, the distribution of brightness, that's the plural, of our images did not match with the distribution of our glyphs. So if you have like a graph like this, we'll make a little histogram here. You could imagine that if the x-axis is like brightness, bright, and the y-axis is like count, i.e. like how many glyphs do we have at each brightness. It kind of skewed like this. So we have like very few, actually kind of more like this, very few glyphs that are bright. We do have some, but they're like very few. And we have a lot of them that are like pretty dark. And so what that means is that we get like better detail in the darker sections of our images. And so we're like, okay, well, what if we just take our normal images, like maybe will look like this, right? And we just kind of like push them to the left, make everything darker, and then kind of like maybe stretch out this part. So maybe we can make our images look kind of also more like this, right? And then we'll get like preserved detail and maybe have them look okay. So let me just quickly pull up a visualization for that. Probably here. One sec. This guy here. I did copy paste the code I needed for this before starting, but we do need to quickly uncomment it. And so the idea is we took like the image on the left and we turned it on to the image on the right so that we get like better glyph distribution. And that seemed to be like pretty successful. But someone in chat was like, why are we doing all this manual work? Isn't this like a stream about neural networks? Because we're using a neural network to learn to generate the correct characters quickly, but we need to like provide a target for what it's trying to learn. And so my initial argument was, well, we should be able to get like, we need a number to correlate with how good do I, a human, think that the output is, right? How good do I, a human, think that this ASCII represents that image? And so I think like my initial thought was that you need some manual human intervention to decide what those numbers should be, right? But I was thinking a little more, and I think maybe he was right, and maybe we could train an AI to do this. So the current thought is, say you have a neural network that produces pre-processing effects, right? The same thing we were doing here, but like we'll let it figure it out. Pre-process. We feed it a picture, image, and then he pre-processes and we feed it to our like ASCII converter. ASCII. Great. So far, so good. Now, we need to find some way to get this guy to produce some form of steps that will make whatever comes out here something that we like better. And so like, what do we like better? And so I was kind of thinking, maybe what we like better is the ability to correlate the ASCII output with the original input image. And maybe that's something that you could automatically have an AI figure out. So here's where it gets a little crazy, right? Let's say that we feed this into a third neural network. We're now at 3. Because when you like hitting stuff with hammers, because you have a hammer, you hit everything with the hammer or something. When you're a hammer, everything's a nail. We're using AI for everything. Fuck it. And the thought was, if you were to take an input image, we'll call it like A, and take a second image, B, and maybe these are like very similar images, but they're like slightly different, right? Very slightly different. if this guy were to pick which one of these images was the ASCII image, right? So we kind of like pick one at random and just kind of feed it in through this step back here. And we say, figure out which one of these is the right one. So we'll call this like classifier. You could imagine that if this, you could then say, if this guy works well, this classifier, you could then say, this guy should learn what he can do best to make this classifier improve its performance, right? So basically, like, how can we adjust our pre-processing steps automatically so that this guy can correctly say, I know which one of these images was the input. And so that's what we're working on today. Last stream, we got to the point where this classifier like kind of works. I fed in like 2 unrelated images, and it could correctly identify which one of them was turned into ASCII. But that's not really like that's not like the hard part of this problem. The hard part is we need 2 images that are very similar, but not quite the same. And so here's what I'm thinking. We take a video, like just like some like videos from the internet, and we take 2 adjacent frames of them so that they should be like quite similar, but maybe like a facial expression changed a little bit. If we use those 2 images, the classifier might have a little bit of trouble if the ASCII that comes out isn't like detailed enough. And then hopefully the network that pre-processes our images will like learn to like put the image into a space that we can ASCII them well and see the difference. Now, there's a bunch of risk here that whatever this set of networks learns is going to be something that like is not relatable to us as humans. And I'm like very aware of that, and I'm just kind of curious to see where this goes. So that's what we're doing today. And so I think that there's a few things that I want to tackle today. One is that the data generation for this right now is like very fucking slow. And it's so slow that it's like not reasonable. Like we wouldn't be able to see any results on stream. And I think that it shouldn't be that slow. So I think that probably if we can speed it up, we might be able to get like some like massive gains there that make it so that at the end of the stream we actually like see results. Right now, even if we got through all of the stuff that we wanted to implement, the ends would still be very disappointing. So let's at least see if we can like fix that problem. Then we'll make like, then I want to like try to make some data loaders that will pull 2 adjacent video frames and pick which one to ascii. Then we should probably look at the data we're feeding the network, because maybe we'll look at it and we'll say, wow, that's fucking useless, right? And if we get all that, then we can actually set up network training, but we might not get there today. That might be a task for tomorrow. Yeah. So let's get moving. We'll say that we're at 8 minutes into stream, and we're going to start at trying to speed up the data generation. So last stream, we got to this like train ASCII classifier. It looks like very slightly different than it did at the end of the last stream. The big difference here is that, oh, I didn't explain like what this guy's doing. Okay. So we took a typical off-the-shelf neural network. We looked up PyTorch transfer learning, and we just like clicked on the link, and we saw like somewhere, was this the one that we used? Or maybe we looked up PyTorch image classifiers. Maybe this is where we got it from. No, Torch Vision. Hold on. We're close. Torch Vision. Was this one? Models and pre-trained weights. Yeah. Okay, so we're like, there must be an image classifier that exists. And we looked up, well, what are some pre-trained models? And it said ResNet. And ResNet's one of the ones that like does image classification. So we use ResNet. ResNet. And he takes in like single image, and he outputs like cat or like dog or like any of other like 1,000 things. And so what we kind of did was like we just cut off like the top of his brain, and we took the parts that we cared about, all of the stuff inside that like extracts interesting information about people, or like images I should say. Then we essentially just run this 3 times. So we get in like image goes into ResNet, and then out comes like features. And we do that 3 times to get 3 images, or 3 sets of features, right? One for the ASCII image. We get like ASCII ASCII features, features from like image A and features from image B. And then we just like slap that through some more neural network shit to get a prediction on which one it is. And at the end of last stream, we had it just so that it was like a single node, but that wasn't effective. So I just kind of like randomly slapped some shit on the end without really thinking about it. And it like saw some results last night. I'm sure that this can probably be reduced, and I probably will try to reduce it later, but for now, this is what we got. Okay, so at some point we like load some images. So we come in here and we say like, hey, when we're training the network, we're going to load 2 images, and if by some like probability, 50%, we're gonna try either ascifying A or B, and then we just like spit those guys out. And this seems to be super slow, and so I want to look at that a little bit. And see, I think that there's some like free gains in here, but I just want to like check it out just to double check. So I think the first thing to do is to like time everything. So the other day we had some timer code that we can just kind of like yoink from over here. So I think it's git show this other branch from the other day, and I think it was in lib image sampler would have been where it was, and we can just yoink this. Here we go. Log time is what I'm looking for. This is what I'm looking for. And probably we should like actually just commit this into like a proper utility, because this is going to come up again and again and again. So from context lib import context manager and import time. And this just lets us do a little like nice little like one-liner that will like log times of stuff for us. So we can go here and we can say, where is this function called? Get images. And we can just say like with, what do we call it? Timer log time. And then we can say what we're calling this, so load image. Then you just indent all this, and we should just get like a free little timer thing at the end, which is pretty cool. Import lib timer. Was that it? lslib? Yeah, lib timer. And as timer. Cool. And I think if I just like run this training now, we should start seeing logs there, which will be useful. Yep. Okay, here we go. So we see some of these guys are taking a long time. Some of them are pretty short, which is kind of interesting. I don't really understand why that is. But we're seeing some of them take like 250, 260 milliseconds. Let's see if it's like similar on both the GPU and the CPU. And it's looks like the bursts are a little worse on the GPU, so we could maybe imagine some sort of like memory bandwidth issues. And let's just kind of like break down where these slowdowns are coming from. So we can say load image A here, load image B here, and then we'll say the other thing we do is ascii, and then we do some like pre-processing to convert our inputs into like what the neural network expects. So we can say log time pre-process. Okay. And let's just kind of see who of these guys is eating us. Or maybe it's not any of them. Maybe it's actually with... Oh, no, it is. It's got to be one of them. Yeah. So let's look. Okay. So can we find one of the fucking slow ones? We should let's stick a print line somewhere here so you can like see everything get split up nicely. I guess it would be here is where we want the print, just so that we can find what we're looking for. There we go. Okay. So here, in the case where it took 100 milliseconds, 160 of them was in pre-processing, 16 milliseconds in pre-processing, 85 in converting it to ASCII, very few in actually loading the original images. Okay, which I think lines up with my expectations there. So when we convert our images to ASCII, we open the image, how do we say this? Okay, let's draw it. We'll get out the pen and paper. And by pen and paper, I mean Paint and Paintbrush. But not real paint, like Microsoft Paint. But not Microsoft Paint, like a rip-off of Microsoft Paint from KDE. Okay, so we have like an image. We load it up. Boom, boom, boom. And we basically say, I'm going to like look at this area, then this area, then this area, then this area. And each of these guys, then I'm going to go like, after I finish this row, I'm going to go like do this row, then this row. Each of these has like a sample size, right? So like you might have like characters in here, and then these got mapped into like one character each. This could be like, I'm an @, and then this guy will say, I'm an X, and this guy will say, I'm the letter I. Then what we do, which is like maybe kind of weird here, is we actually render out an image based off of this character map. So then we have, let's see if I can find it here. We have like a stamp of each possible character that has like a fixed width and height, which is like not really how font rendering is supposed to work, but we can tackle that in the future, right? If we get this like stamped version to work correctly that assumes that all characters are the same size, we can always adjust. If that works, then like the whole concept of the project works, and then we just have like a slight little fix to do at the end, so no biggie. And so what we do is we just like take that and we stamp each of these stamps into a new image. And I would suspect that stamping process is probably pretty slow because it's doing like basically a loop over each sample in Python land. And general rule of thumb in like this like Python land neural network training, the general rule of thumb is don't loop in Python, right? Because Python interpreter is fucking slow. Not like actually slow in a way that a human would ever really notice doing anything normal, but in the case where you're doing like a lot of processing in a row, the Python interpreter starts to become noticeably slow compared to maybe batching up operations and running them all on the GPU at once. So I would expect that this is probably where the pain is coming, but we should probably prove that in some way. So when we go into, well, let's do some like more time logging. Let's do some more time logging. So we'll delete these guys. We know now approximately where the pain is. And let's just go back over here now. Where were we? Somewhere we load the image here. So we can just double check. I expect that we're going to find that the bulk of the time is coming from this render here, but we could also see it might be coming from actually running the neural network and predicting the characters. So we can say with timer log time, label samples, and then we can say with timer log time render image. And I guess just for completeness, we'll also try to do a catch-all for this stuff here. We'll say load samples like this there. Okay, let's run her again, give her a little peek. Okay, so here, okay, here we go. Load samples 2 milliseconds, label samples 10, god damn it. Load samples 2 milliseconds, label samples 14 milliseconds, render image 100 milliseconds. Yeah, so the rendering image is the like massive slowdown, or like at least the biggest bang for buck. And I'm pretty sure that we can probably get in there and just take a, we can, I'll bet you it's this loop, right? So we can also just check that. So we can say timer log time glyph render loop. We'll call it. And this is a with statement with timer log time, which means that we need to import timer as timer, I think. That should work, I think. I don't know. He doesn't like that import dot timer. From dot import timer as timer. Maybe I don't need to do that. How do I import like just an adjacent file like that? There we go, that's working. Okay. So render image, the render loop is pretty much the entire thing. Render loop, 65 milliseconds, 65 milliseconds, 60, 60, 58, 58. Yeah, it's pretty much the whole thing. Okay, so here's what I'm thinking. I'm thinking we can just get rid of this loop, right? Because what we have here is we have like an output canvas, basically. So we have like our, we have input image here, input, and then we have output, which is like a different size, output. And we're basically saying like, I'm going through each label, boom, 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 and I'm just copy pasting my stamps. So I have my like stamps over here. And I'm basically saying like, which stamp do I put here? Then which stamp do I put here? Then which stamp do I put here? And you could like probably compute all of this with like on the GPU or on the CPU with like PyTorch optimized code, and then not have to do this like loop in Python. Probably. So we have our labels. This is just like an array of indexes into the glyph cache, right? So this is going to be like, we're going to have number of samples, items, and each one is going to be like an index into the glyph cache. Then we have our output, and he's also going to be num samples. That's not true. That's not true. He's going to be num samples times sample height, or times glyph height times glyph width. That's his size, right? Because he's going to have to stamp a glyph for each sample. And so what we just have to figure out how to do is how to split up the output into the way that like we can basically just stamp all of them at once, right? Because if you were to say, I have my glyph cache, which is like all of my stamps. If I were then to just shove labels in here, this would give me a sequence of glyphs that is like perfect for the image. All we have to do is figure out how to like stick them together. Which I guess that means this would be something like num samples by height times width, or maybe even by height by width if labels is a 2D array already. And so then we just need to convert this into pixels. Yeah. Okay. So we have like, if we have sample, like say this is like a linear array of samples. We'll just think about it that way for now, because like the way they're laid out in memory, that is how it works. So what actually happens is you're going to, in memory, it's going to look like this. So it's going to iterate like horizontally across the first sample, then vertically across the first sample, like this, then horizontally across the second sample, and then vertically across the second sample. And what we actually want is we want it to go all the way across like this, right? And so I think there's probably just some sort of like conversion you can do here that will like make this line up. So let's think about this. We have num samples by sample height by sample width. And we want this to go to, I guess we're going to have to break this up a little bit. Let's say num samples y, num samples x by height by width, right? And then we want this to actually turn into num samples y times num samples x. Let me think about this. That's not true. For each row, let's just think about one row of samples for now. So we'll just think about the case where we have number of samples on a row by height by width. This should just turn into num samples x times sample height by... Nope, this should turn into sample height. Yeah. The first thing is the height, so we're going to iterate row by row. Num samples x sample width. Yes. Okay, yeah. So if we just do this swap here of dimensions, if you think about like iterating from the outside, like the left is the last thing we iterate and the right is the first thing we iterate. If we have width by height by samples, that's width that's like this thing again, right? Like width by height. So we do width is this, width, then height. So we go height, then samples, 1, 2. And if we reshape that so that it goes width, samples, height, then we have like 2 samples like this, and we'll iterate the sample width of 1 first, boom, and then we say, what's the next thing we have to do? Oh, we have to go on to the next sample. So we go here, and then we go here, and then we go here, and then we're like, oh, wait, now we need to go onto the next row of of each sample. Boom, boom, boom. And the way that this gets like placed in memory just means that that will line up perfectly with the image. So then all we have to do, then if the last thing is to iterate samples this way, that's free. We don't have to do any like sort of reshaping, because like if the samples are stacked vertically, then when we get through all of these samples and move on to the next row of samples, we'll just start at the top again. Boom, 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 boom. I'm like 80% sure that's correct. And we can just see it and find out. So, okay. Let's look at our labels shape is probably num samples sample height, or num samples label. Our glyph cache, which would make our glyph cache probably this. And so let's see if we can get this to be number of y samples, then by label. It doesn't matter. Fuck it. We'll just keep it like this. Okay. So what we should see. Oh, let me think. Let's just print the shape of this, and we can confirm and move on from there. Okay, so he has 7,990 samples for a single image by 36 by 22. So 36 is the glyph height, 22 is the glyph width. So that makes sense. And so now we just need to break up this like num samples into num samples y and num samples x. So we should be able to say n height, sample width is equal to this guy. And then we just say ny is equal to n over cars per row, which we're already tracking. And nx is cars per row. And so now we should be able to say self glyph, we'll call this we'll call these samples, I guess makes sense, is what we should call this guy. Or stamps. I like that better. These are the stamps that we want to use for this image. And we now just want to say stamps reshape. Why is it not autocorrecting? Whatever. Stamps is equal stamps reshape, and here we have to do ny by nx by sample height by sample width. And then I think all we have to do is say stamps is equal to stamps.transpose, i.e. flip 2 dimensions, like we were talking about before. And we should just have to flip dimension 1 and 2. And I think if we just turn that into an image, that will just work. So then we should be able to say stamps is equal to stamps reshape into like pixels instead of samples. So I think that should just be number of y times sample height and number of x times sample width. And maybe. Who fucking knows? There's a good chance that that's not right. But there's a slight possibility that it is right. Maybe. So let's run the visualization script, because the visualization script also runs this code. And then we can actually see if it is correct still. So we can go visualize, we can go here, and we'll just open up this image in the new tab. Oh yeah! Let's go! That actually worked. Okay. Damn. I love it when it comes together. And now we can run our train script and we can see how much fucking faster it is. Oh, that feels so much faster already. We're at like 60. Okay, let's maybe we can do like a before and after. So let's go to train ASCII classifier, and we will get rid of some of these times, and we'll just we'll log time for like the whole batch fetch. Because I think that'll kind of show the difference a little better. Okay, so we can say with timer log time get images. So with that improvement, oh fuck, we have some prints that we want to get rid of. This. Python 3 train ASCII classifier. Why is there still log? Oh, because did we log time in here? Where are these spams going? Label samples. Label samples. Oh, here. Oops. Oops. Here we go. Ditch all this shit. We don't need this anymore. We don't need that log. Those logs. Just the big one. Okay, so. Oh my gosh. Okay. Sorry, it's doing some stuff. So 1.2, that's still really slow. 1.0. Wow, there's also something else that's clearly slow here. So 1.0, 1.2 from what were we at before. So let's get status, get add-u, get commit-m, faster, maybe image rendering. And can we then get checkout lib image to get checkout head -1. We go back for lib image to text only. Now we run it again, and we should see the old version. How long did that take? So we were at like 1.2 for the batch. 2.2. So we shaved like half the time off, which isn't as good as I thought it was going to be. There's still something else that's pretty expensive in there. But we did save off like a whole second, which is pretty good. Yeah, 2.7, 2.3, down to... Oh, is this on CPU? Let's go to GPU. Oops. But on the new one. I want GPU on the new one. Fuck. Get status. Get checkout this. Discard everything? No. Get restore. Stage this, then get checkout this, get status. Everything's gone. Okay, sorry, let's do that. Fuck doing things on the CPU where it's slow. We want to do it on a GPU where it's fast. And maybe see how bad it is. Okay, there we go. Down to 0.3, 300 milliseconds per batch. It's not great, but this is like orders of magnitude. Like this is way better than it was before. Actually, we should have checked the other one on the GPU as well. Fuck. So let's check out head -1 on that and run this on the GPU and just see approximately how bad that is. Give her a sec. One more. Oh my god. See, this is what I was talking about. This was painful. Holy. Holy, man. Okay, give it a few more seconds. Okay. 7 seconds for loading a batch before, down to 0.3. So what type of speed up is that? 0.3 out of 7. 7 out of 0.3. 23 times speed up? Oh, more like 6. 20 times speed up? I'll take it. You know, that's significant. Very significant. So let's call that done. And the next thing to do is make a data loader for JSON video frames. So we have our data loader. Well, calling it a data loader is it's not really much of a loader, but we have our train ASCII classifier, who right now, he has a get images here, who just kind of at random, he issues like a random thing for the number of samples that we want, batch size, And we just kind of like take random indexes into a list of images in a folder. And we need to adjust that to take 2 adjacent images from a video. Sure. So what do we want to do there? Probably download some video from the internet. Big Buck Bunny. This is the classic that I use, like everyone always uses. Is this like the video compression demo one? I don't know why I've seen this video so many times, but I'm pretty sure it's copyright free, which is why I see it. Yeah, the fact that it's just like in Wikipedia indicates that it is. Probably 1080p is too big, but we can maybe... we're processing... Our image to text thing expects things that are approximately 500 pixels wide. So is 360p or 480p better for that? 360 times 16 over 9. 360 is probably what we want. So let's... Or maybe even 240. 240 times 16 over 9. Maybe 240. And then the image classifier expects things that are 220 by 220-ish. So 240p kind of fits into that cleanly. Yeah, okay. Let's download the 240p version of Big Buck Bunny and just kind of see what that looks like. So I think you can like Nix shell YouTube dope. YouTube DLP, and then I'm just gonna have to look up YT DLP pick quality. How to select video quality from YouTube, from YT DLP, not YouTube DL. I guess, yeah. -s res, okay. So YT DLP -s res 240 this. Okay, sick. So we have this guy now. And can we just like VLC Big Buck Bunny? Okay. And if we are to step frame by frame, which is not that button, VLC next frame. Which button is it? E. Okay. Yeah, so we are seeing like very slight changes here. Can we like go into like the actual video and hit next frame? Those are pretty aggressive changes, but maybe that's the kind of thing that I was looking for, where like you have very, very subtle changes, and hopefully whatever our... Oh, these are like literally identical. That's not good. Oh, they're changing. Yeah, very subtle changes. And hopefully the image to text network or the pre-processing step like learns to produce image kernels that amplify these small differences. Hopefully. We'll see. But I think that does look kind of like what I was looking for. We'll see. Okay. So we have Big Buck Bunny, and what's like the easiest stupid thing to do here? We'll make dir Big Bunny, and can we just like split the video into images with ffmpeg? Before you start working on stuff, did you restore the git status back to head? Yep. Good catch. Also, like I'm very familiar with making that mistake, and it actually turns out it's not a huge deal because you have like the ref log. So even if you commit something to like the wrong place and then find it later, it's like not the end of the world. Oh, or you mean the git status? Ah, yes. Sorry. No, I did not. But we would have, I guess, figured that one out pretty quick when it was slow as fuck. But thank you. Okay. So we have Big Bunny folder, and can we just like ffmpeg split video into frame images? All right. In out M4A. Oh, you can just image %4d.png. Easy. Easy. Why are they splitting out? Oh, I don't care about that. That's fine. Okay. So here we have / big buck bunny, and we need to put that in quotes because that's a disaster. And is that it? It's doing something. ls? Yeah, all right. And then probably if we open up that folder with Gwenview, just like this folder. All right. He's kind of losing his mind, but can I just like open one picture so that... how do I like... Next image. Okay. Yeah. That does seem like it's working. Cool. And now let's do our test where we can visualize what the ASCII network will do to this folder. Nope. Wrong folder. Not Val. I want Big Bunny, please. Let's take a little peek skis. He's not happy. Because my nested directory image loader expects JPEGs, because that just happened to be what I had. So let's just quickly switch this to, say, PNG. Just as a little workaround. They're not sorted, which makes this kind of... Dude, that's terrifying. What the fuck? Oh my god, I hate it. Okay, let's also sort them. Just so that when we skim through, we get them in order of how they appear in the movie. Great. That's super cool. Oh, here we go. Okay, so we also might have to do... Oh, there we go. You see some movement. This is clearly not the best way to do this, but can we go to, like, image, like, 500? Like, just... Jeez! Oh, God. Hold on. What's the hack here? We go into index.js. We initialize our first image ID. Instead of it being at 0, we just want it to be, like, somewhere reasonable, like, halfway in. So I think somewhere we have, like, an image updater. Yes, yes, yes. And here we say, start at 500, please. Visualize. Refresh. Hit next. There we go. Okay. Yeah. Okay, so this is, like, the type of thing where it'd be really interesting to see if they can create better correlation after doing something to the input. Because that's, like, really fucking hard. Like, yeah, and it looks like shit here, also, which is pretty funny. Okay. Sure, fuck it. I mean, also, even if we can't always get... Even if, like, the two side-by-side images aren't always, like, super easily distinguishable, or maybe, like, don't have to be, as long as, like, the number of samples where it is reasonable is high enough, then hopefully this will work. Hopefully. I don't know. We're kind of flying by the seat of our pants here, and we'll just kind of see what fucking happens. We'll just see what happens. So we have our train ASCII classifier, and here we'll just make our get images do something different. So first of all, he has, like, an image sampler. And I guess he's using nested dir image loader, which we can just keep doing, because we'll just make sure that we'll sort the inputs. And then I guess here, probably all we have to do is say that our random IDs go from 0 to batch size, And we'll just say image B ID is image A ID plus 1. And we just have to make sure that we don't ever get to the last frame, so we just say batch size -1. And I think that'll work. We should probably make a visualization for kind of this as a whole, but we can just bang out a real quick one for that. What are your specs? We have a LS CPU. Have a i7 9700K, 16 gigs of like okay RAM, not like the best, not the worst, and then a 6700 XT for my GPU, which is great for Linux. It feels pretty good. Open source drivers is a good meme. I've been playing Apex at 144 FPS without any major problems, other than like I kind of have to like kick the GPU scheduler into high gear sometimes. But otherwise, pretty good. Yeah, pretty happy with it. Pretty happy with it. Okay, what was I doing? I wanted to quickly see if we can bang out a visualizer for this. So just to make sure that like the inputs here are reasonable. So what do we want to do? How do we want to do this? I guess, what will like the web UI version of this look like? 3 images, 2 buttons. Pretty straightforward. Sure. So I would have thought you have significantly more RAM. Yeah, dude, I would too. I need to buy some because I get pissed off like maybe like once or twice a day because I run out just doing like normal shit. Like if I just like try to like watch a couple of YouTube videos and play a video game, it's like, or sorry, I don't not watch a couple of YouTube videos at once. That's insane. Who would do that? But if I try to watch like a couple of YouTube videos back to back and then play a video game, like just sometimes that just like fucks me. And then my like the scheduler on Linux, I don't know what's wrong with it. It's so fucking stupid. And it just like I've never once been able to wait out the killer. It's just always like the music starts looping because the audio buffer never fills up. And you get that whamp, 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 and then you go hard reset the computer. Every fucking time. And it's a solvable problem for real cheap. I just don't do it. All right. So visualize. I guess we'll do something similar to our other visualize script where we have a web server who inherits from HTTP server. And he pushes things into a request handler. And the request handler implements this like do get function, who basically just writes to a file. Cool. So what do we do here? There's like you extract from the path. We'll just say we have what are our options going to be. We're going to have input ID. I guess that's it. I guess we'll have update, which will call get images with like the expected value. And then we'll have like the ability to get image A, B, and ASCII. And that's probably enough. I don't know. Maybe update we'll just call random. That seems reasonable. Seems reasonable. Yeah, okay. So we'll say if self path is equal to update, we cache new images. So our server is going to store the output of this guy. Yeah. So we'll say self server images equal to get images. And then we're going to have to store all of these inputs in here. So the batch size is going to be 1. Unconditionally. We are only going to get 1 set. Sampler, we're going to have to save this guy. So we're going to just say, I guess we just copy paste these arguments here. Yeah. Paste. And we'll just replace them here. So batch size is 1. This comes from the server. This will come from the server. This will come from the server. this will come from the server. Easy. Which just means we need to store those things. Which means that the arguments of this guy are going to be very similar, actually. He's going to be boom. And then we copy all those, we paste them here, and we do a little vim macroing to be like self.thing equals thing. Boom. Boom, boom, boom. Self.preprocess equals preprocess. Boom. I guess we need to, let's get those like fucking annoying import things out of the way. Boom. And here we can just throw a little assert is instance self.server is a visualizer server so that these little arrows down here go away. And here we'll just, this is none. Alright. What is this complaining about? Cannot assign. If only it wasn't running off the side. Expression of tuple. I guess we don't care about the labels. Just, yeah. Sure. It's complaining, but that's fine. If self.path is equal to A, we have to write out the thing as a file. So we do what? Image self server images 0. Oh, I guess the initial thing of this, also, we should initialize this with something that is reasonable. There we go. Okay. And all these guys that say server in this version just don't. There we go. Okay. So if path is A, we serve that image. And this image is going to be in some like weird fucking pre-processed space. So we actually have to like invert probably something. But I guess we'll just serve it as is and then see how fucked up it looks and then fix it later. So this is going to serve the first thing. This is going to serve the second thing. And this is going to serve the third thing. Yep. And then we just have to write out these things as files. So we have an example of that somewhere. Image. Right, so we convert the image into array. So let's see. So we'll just do the same thing for all of these, and then we can do a image from array, image CPU numpy, dot save to the output file in PNG. And then we just have to tell the server, tell the browser, sorry, that we are sending back an image. Yeah. Which should be something like image PNG. And we'll just say 200 here because I don't want to deal with that import. And I bet you that will work. So let's, instead of training, skip that shit. And we'll just construct our server. Which looks, this is the stuff that I need down here. And we need to pass in all of these arguments. These guys down here. So we just copy, paste, boom. And hopefully all of the names are the same, but they're not, because they never are. So net is the image to ASCII net. Preprocess. We need to tell this guy to take in any additional arguments and forward them to his parent. init args kwargs. Okay. And then we need to close the bracket. And server serve forever. Really, we should put this behind a flag, but you know. You start somewhere and then you iterate when it pisses you off. Well, and by you, I mean me. That's how I operate. Ran int does not work because I passed in the wrong folder here. Big Bunny, please. Big Bunny is where we're pulling our images from now. Which he doesn't like now in 178. List index out of range, which is interesting. Interesting. Why? Print hello. What's happening? So he's never running in there because I'm saying for image in this 0 to num images, is my num images fucked up? No. Let's see. What is this? What is this guy giving us? You know, let's just take a little peek skis. What's he saying? Empty list. So what the fuck is my batch size? Oh, I'm an idiot. I shouldn't be doing batch size -1. I should be doing num images -1. Whoopsies. Whoopsies. Okay. Now we have a server running at localhost 9999, and we can look at image A, which was supposed to give us a PNG, but he's not because the image to tensor to image conversion is broken. So it's this guy here. We have image. So I think PIL is probably expecting something that looks like height width, and we're giving it something that's 1 height width. So we could just say squeeze it, baby. I think that's what it was complaining about. Refresh again. He still doesn't like it. Where is he bitching? It is right here. So the squeeze is not doing what we wanted. But it's claiming that we have image is equal to shape. He's saying that it's AB height width. And then we should just be able to say image reshape HW. I think that should be fine. You're saying HWs or width height channel. I'm pretty sure it's expecting height width, not width height. Oh, invalid for size. Oh, because this. What the fuck is image.shape? What is this? Refresh, sorry. So image shape is 33224. I'm just a fucking idiot. Because this is coming in batches of 3, so we need to extract the batch here. Now let's take a look again. So this is now not enough values unpacked, expected 4.3, and so now this is channels height width, and we need to turn this into a height width channel. So we can just do a image is equal to image.transpose. We want to transpose. We have CHW, and we're going to go HWC. So I guess we need to do 2 transposes. One to flip C and H to go to HCW, and then one to do the second 2 to go to CHWC. Yeah. So we transpose 0 and 1, and then 1 and 2. Easy. Easy. And then no reshape here. And then hopefully everything works out. Refresh. Still doesn't like it. Still does not like it. So here he's 224 by 224 by 3. But he's still not loading that. Cannot handle this data type 113. 113 F4? What the fuck? Oh, what's my data type? What is my data type? it is float 32. So it can't handle 3 floats? Am I high? I'm just gonna... Does this, like... Okay, good. Somebody else has hit this. What the fuck is they saying to me? Oh, I see. They don't like it as floats. I see. So here we should just be able to do what? Image times 255 to torch.uint8, then to CPU, then to numpy. Let's see. Come on, baby. Oh, okay. So we're close. He is not getting back the content header that I thought he would be getting because we forgot to type end headers like this. Maybe. Who knows, you know? Okay. So that's something. So we have A, B, and what was the third path we said that we were going to support? A, B, and ASCII. Okay. Okay, so we do in fact see that we see movement here. And I should, as a human, be able to guess that this is... I think that the ASCII is from A. No, from B. I think it's this one. But also this is like really fucked up. So I bet that we're like, we're wrapping around probably. Because I bet you if we looked at our mean and standard deviation, or let's just look at our min and max. Print image min and image max. I bet you it's in like some like fucked up position. Let's also else return just here, just so we're not in like this state where we might try to access invalid memory. So yeah, we're seeing negative 1.6 to 2.4. So I happen to know from when we were doing this the other day, when we looked at the pre-processing that we do for the image classifier input. They do this like normalization shit where they apply this standard deviation and mean. So they say like the mean of all images in the world is this guy, and the standard deviation is this guy, and then they basically try to like put that into the range of -1 to 1. So they do like I'll copy paste this 1 sec. They do like image minus mean divided by STD, I think. And so we just have to invert that. So we just can do probably image times 229, 0224, 0.225. And then I think that we probably have to torch tensor, put this guy on the right device. And we might have to reshape him so that he broadcasts correctly. So we can say 113 or something. 13 maybe. 113. Yeah. And then after we multiply him, then we can add the means back. And hopefully that does the right thing for us. I'm actually kind of like partially guessing here. But we'll see. So if I run this now and then I hit refresh. Look at that! Those are reasonable images, kind of. And are A and B, like, essentially identical? Oh, they're very... This is going to be fucked. Okay, so if we call update now, that should give us new images. Nice. Oh, look at that very, very subtle difference there. This ASCII one is not giving me the right image, which is kind of fucking weird. What the fuck? Why was the ASCII one giving me a non-ASCII image? There, that's ASCII. Oh, yeah, okay. That's one. Okay. Okay. Cool. So it looks like the data that's coming out is like somewhat reasonable. Do we want to go through the effort of just banging out a quick little thing that we can hit the next button on? Yeah, why not? Why not? Because it's kind of fun. Elif path is equal to just the root. We return some HTML, which I think is just whomp, copy paste this guy, and then we skip everything in the head. Probably, I guess, we're gonna want to have actually a head that has some JavaScript in it that will attach the buttons. So in our body, we're gonna have just simple image source equal A. And then we'll have source equals B, source equals ASCII. So even here, actually, this should give us something interesting enough if we just refresh at the root here. No? Why? Does that have to return? He doesn't like it. He doesn't like it at all. Why? Does he... Oh, because I didn't actually do anything with this. I'm an idiot. Output is equal to this. And then we self send response 200. And we send header with content type is application HTML? Text HTML. Maybe. We end the headers, and then we self w file write output. All right, that should do it. Refresh. There we go. Look at that. Okay. Just quick, simple initial visualization, and then we just like smack on two buttons. So input type equals button, I think. Is that right? Input, and then we say next. Preview. And then we should say, oh no, we don't have a next and preview, we just have update. And then we say on click update. Do we put this in quotes, maybe? I don't know. And then in here, function update. Is it function in this language? Maybe. Console.log. Hello. I'm so fucking lost. Console. Oh, yeah, okay, he's saying hello. Sick. Yeah, that's not what I want. Oh, you're saying do button instead of input type button? Yeah, because that didn't look like what I wanted. Boom. Button. Try again. Okay. Cool. So now the only thing that I have to do is force a reload of these images, and I actually don't know if that's possible. Force image reload HTML. Refresh image with a new one at the same URL. Dude, that's so fucked. But sure. Yeah, alright. You know what? You can't complain. Can't complain. So I guess these guys need IDs. ID equals A, B. And this is ASCII. Then for each one we say document get element by ID A dot source equal to A plus that shit. B ASCII. B ASCII. And then we switch these to be starts with. Starts with A. One more. Couple more. Path starts with and then B. This is really not even important. Like, this is gaining me nothing. It's just kind of fun, and I wanna stretch the muscles a little bit, you know? You know? Refresh, 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 refresh. Oh, wrong one. Refresh. Update. Update, update, update. Ah, fuck. Do we have to wait a little bit? Oh, I mean, update isn't actually calling the update. The one important function, actually. Fetch. Update. Dot await. Can I make this an async function? And it's not dot await, it's await here. Refresh, 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 refresh. Update. Network. Update. No. He's not doing anything. Why? Why? Why is he not doing anything? Console. Log. Hello. Why? He should be doing something. Is it because is it really, can I just not do an async function there? Oh, also ASCII starts with an A? Yeah, that's a really good point. Why is this not doing anything? Am I fucking high? Oh, because I removed the on-click. I'm just a fucking idiot. Yeah, you're right. You're right. On-click is equal to update. I thought I had that already. I guess I accidentally deleted it when I switched to the input to a button. And you're right. ASCII does start with AA, so we'll just quickly, temporarily, for this fucking bullshit, swap it around. Hey! There we go. Cool. That's not good. I don't know why that happens sometimes. Like, something weird is going on here that we have to look at. So get images. Print. Yeah, there's a bug there, which is kind of why it's good that we did this. So let's look at the output of here. So we have, oh, it's because I'm an idiot. I'm supposed to always unconditionally generate image 3, which is the ASCII image, from... Yeah, okay, that makes sense. So it was just 50% of the time it was bugged. Okay. 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 Okay, yeah, that's pretty sick. It looks like it's kind of working. And I wonder if we'll be, if like it will actually be able to tell the difference between these. But I guess that's kind of the point. Sick. Okay. So I think that we can say that we've made a data loader for adjacent video frames. I think we can also say that we've visualized. And we kind of will like fold these into the same thing. And so now let's kind of set up a training loop here. Yeah, okay. Is that what I want to do? I guess I'm concerned that because of that bug I just fixed, where it was sometimes not producing an ASCII image, I'm concerned that my previous experiment didn't work correctly, where I actually generated, where I like trained a network that could correctly classify which image things came from if they were completely unrelated. I'm not really convinced that was correct anymore. So I think, let's do this. Git status, git add -u, git status, git status, git commit -m, test, adjacent image loading working. And I guess we can actually, if we just run the same training script with a different folder that doesn't have actual relation, if I just run this on like the val section, oops, except val has JPEG, so we actually have to fix this. Can we like, can I say that these will be PNGs or JPEGs? Is there like, can I do this? I just glob format Python. Can I, Or I can also just, can I, like, self.images append the same thing, but with JPEGs? And I think append is probably the wrong word here. Is it extend? And I probably don't need to convert these to a list. Probably. It'll probably just iterate these automatically. Maybe? Who fucking knows? There's only one way to find out. Refresh. Okay. Cool. So this... Okay, so if everything is working correctly, if we run training with this, we should be able to... What the fuck? Oh. What's going on here? Why does it look like that? Weird. That might be a bug. It might be a bug in the conversion back to image space, but whatever. Oh, we're seeing it a lot, actually. Oh, that's weird. Yeah, what the fuck? Should we ignore that? Oh, it seems bad to ignore it, right? Can we just... Like, what am I saying? Maybe this is like an artifact from the resizing of the image, like, after normalizing. Because that's, like, fucked up. Oh, yeah, we need to look at this. We need to look at this. Ugh. Fine, I'll fix bugs. Jesus. So, investigate weird checker pattern on ascii. Because that's clearly not good. Clearly not good. Yeah, that's fucked up. Okay. So I guess, let's just also return the original for now in our train ascii classifier. Okay, just temporarily, we're going to replace image B. Okay, wait, hold on. Git status. Git diff. Oh, that's fine, yeah. So for now, we're just going to replace image B with the... Oh, we can't. Fuck. Let's say we'll just return source here. Source is source images and or ASCII images, we'll call them. And we will just say ASCII images dot append no preprocessed image 3. And then when we visualize, we can just say one of the things that we can do is we can get a pre-processed, and this will come from just 3, the third thing, which is ASCII images, and not the 3 is in the third thing, 2 is in the third thing. Yeah. And then we will just also put in a pre-processed. Yes. Yes. That seems reasonable. Maybe. So I refresh this. Refresh. Why am I... This is not working. Open image new tab. Pre-process is not working. Index 2 is out of bounds for dimension 0 size 1. So I got it wrong. It's not 2 0. It's... Wait, should it not be? Oh. Oh, I see. I see. So we're going to say the images is going to be everything. We just throw an extra 0 on all of these guys so that we can then extract the 2 thing here. I'm not quite sure this is right. The images that we're getting in... No, we'll see. It'll be clear pretty quick. Dimension out of range. because we tried to do a transpose on it. That's true. That's true, because the thing that we get here isn't like the normal shit. So here we have to take a different path. Unfortunately. But I think it's pretty fine. I think this is going to be it. Maybe. Who knows? We'll see soon. Print image.shape because I don't trust myself. And let's see it. Refresh. There we go. Okay. So that's coming up now. If I refresh here, I am seeing the source here, which looks like that horse. Why does it just look like so dark and fucked up? Right? Like, this is supposed to turn into this? Like, there's a bug here for sure, right? It's just like way too dark. Oh, wait. The left, I'm showing the pre-processed one. Okay, let's, or the processed one for the ResNet. So I actually want to put out ASCII source images as well. ASCII images is here. ASCII source images comes from... Couldn't you do something like glob path to images plus E for E in star JPEG PNG? Certainly. Yeah, that sounds more complicated, but you're right, that does seem like something that would like probably work. It's just some syntax I didn't know about. But yeah, that makes sense. Or I guess I did know about it, I just hadn't thought of it. You're right. So what am I pushing in here? I'm pushing in source image is equal to image A, otherwise image B. Okay, there we go. Then we say ASCII source images append source image, ASCII source images, and then we do this guy is instead going to come from the source image. Just temporarily so that we can compare. Refresh. Refresh? Why is this not doing what I want? Dimension out of range? Am I high? Oh, I have to do this shit again. Fuck. We're hacking it up. I don't care. Don't care. Because this is scratch debug code. Still not working. Why? Isn't image B now supposed to be B? Ah. I have made a mistake. Somewhere critical. So somewhere here, when I pull from image B, why is this fucked up? Print image. Oh, we do print image shape. What image shape do we get for image B? 772? Just flat? Why is it only one dimensional? 0, 1, 2, 3. ASCII source images comes from source images. The fuck? Print source image shape. Source image shape. Am I high? Why is that single dimension? 512 by 776 just goes to straight 776? Aha! I had an extra dimension on there. I was extracting one row from the image instead of the full fucking thing. There we go. Okay, now I refresh here. And we have the source image here, which seems wrong. Fuck. Right, like, we know that this isn't what it's supposed to look like. Which means that something is bugged. It could be that the pre-process step from the ResNet thing is modifying the inputs. That would be fucking annoying. What is he doing? What is he doing? F resize center crop. Image equals normalize image. Like, normalize. Yeah, fuck. Okay, so he is just modifying the guy directly, which I guess we should have seen coming. So can we just, like, clone like this so that, like, it fucks off? Don't fucking touch my inputs, please. Does still look wrong, eh? Like, what is this? Oh, is it because I'm doing some, like, weird... Am I doing anything stupid to it when I write it out? Image times 255 to torch uint 8. Nothing in there looks stupid. Then I return. Why does it look like that? Convert, open path, convert it to black and white. Don't fucking do anything. Hey, I'm not really seeing it. If I just don't do any of this pre-processing shit, which will break all sorts of stuff, but I don't really care for a second. Fuck, I do care a bit for a second. I do care, just a little bit. Just a little bit. Ugh. Fuck, that's... stuff will break. I guess we could say comment all this out, and then also comment this stuff out and return nothing. That might work. Just because I want to... Okay. So if I go back to this now, and I hit update a couple times... Why does it look so fucked up? Like, what the fuck is that? Why? Why does it look fucked? All I'm doing is opening the image, directly just shoving that straight into, like, this source image. Image A, else image B. Oh, because I'm multiplying by 255 when I shouldn't. Ah, I bet you that's it. That's much more reasonable. Ah, so it was just a visualization bug. Hooray! Love that. Okay. So now we can undo a bunch of the shit we did. This should be this. This should be this. This should be like this. Probably. I think the rest of this makes sense. Pre-processed 2.0. Data goes to data. This gets uncommented. We don't need the ASCII source images anymore, do we? No. No, we do not. All right. I think all of this makes sense again. All of this makes sense. So if I refresh now, give me the data, please. Okay. Yes. And can we just hide this for a second so that my fucking everything isn't so fucked up? Okay. So we still are back onto this weird checker pattern shit, but we're closer to the real to the right answer. So let's actually unhide that thing again. Where do we go? Here. Come back, baby. Okay. So here we have what is just like a reasonable image, right? This is like the pre-processed thing before we feed it into the normalization function. I see. So probably what's happening is the normalization steps from, what's it called? ResNet is creating this weird fucking checker pattern. So what is it doing? What is it doing? It's just got to be... It's got to be either the resize or the normalize. So I guess we can maybe try to visualize each of those pieces on our own. So what we can do is What's going on? C++ question mark? Not sure what you mean. We're working on... Are you asking if we're working with C++ right now? Magic? Not sure. Are you... Not sure what you're asking. Sorry. If you try rephrasing, maybe I can address, but not entirely sure. Not entirely sure. Okay. So let's say that we're going to import from Torch Vision transforms, import functional as f. Yes. Then, oh, we already have that. Fuck. As f transforms. Okay. Or maybe we'll just import it as transforms. That makes sense. Then we can do whatever these guys are doing here for their pre-processing. And we can just try to apply that to our image 3 manually. And we can just skip pieces of it until it looks right. Okay, so image 3 is equal to this. Don't do this. Or I guess do it down here at the end. After we do all of our pre-processing manually, we stick it in like we're supposed to our output. And now we can just comment out everything here and just start with the resize and see if that looks fucked up or not. And if it does look fucked up, then we've got the right answer. We need to take out the resize size interpolation. Fuck. Which will come from here probably. Image classification, crop size. Oh, we also will actually need to apply center crop here, otherwise the dimensions of everything won't match up. Look! So the crop size we have is 224, easy. Resize size looks like 256. The interpolation looks like bilinear by default. So we can say interpolation mode bilinear, nice. And anti-alias mode is equal to warn. And these shouldn't be F, these should be transforms now, because we renamed it. Okay. Yeah. Sure. Yeah. Let's see if that at least runs. Fuck! So it's because it doesn't like the warn, probably? Oh, maybe we have to specify interpolation. We have to... These guys are named arguments. Like this. Let's try that again. Let's try that again. Refresh. What the fuck is that? What have I done? Why does it look like fucking crazy ass shit? What the fuck? This shouldn't be doing anything crazy. We're just doing a resize and center crop. Why does it look like that? Why does it look like that? Am I high? It's funny because you can see it like clearly like somewhat keeping shape. But it does just look fucking stupid. Maybe because this guy was supposed to be converted into a floating point before doing that. Print image 3D type. What the fuck is he? Refresh. Open a new tab so we can refresh this and just see. So he's a... No, where did I log? Uint 8? Yeah, so maybe he's supposed to be a floating point at this point. Although they don't convert him to floating point till later. So when we try to get the ASCII image... Oh yeah, we do assume that he's... Yeah, we assume he's normalized. I see. So we do... If we don't apply the normalize, then it'll just look fucked up. I see. So let's apply those. 0.485, 0.4856, 0.406, which I'm copying from the right side of my screen. 229, 0.224, 0.225. Image possibly on brown, and this should be image 3, like this. No parameter named std on f normalize because it should be transforms, not normalize. And hopefully that works out. Input image should be type float tensor. Oh, so we need to do the float conversion as well. So we actually have just done the whole thing, actually. It turns out that every single part of this was required. So we're actually gaining no information by doing this, which is super fucking cool. Very fucking cool. But at least we'll see if we get the same bullshit. Okay, so we have got the same bullshit. And now we can start trying to play with stuff. So, let's try not doing the resize and just center cropping to 224. Which is not giving us very much information, hey. But it also doesn't look fucked, which is a clue. It could be like the interpolation of our resize. Could be. So we have a suspicion that it could be related to this. So we can actually ascii images.append. We can just append image 3 after the resize and see if it looks fucked up. And that will give us a clue, maybe. Maybe. We just need to figure out how to show that image. So clearly it's fucking broken because what are we serving when we get the original? Pre-processed. We are just serving the image as something. Something. So he doesn't like image to torture you. Okay, so we have to do the like transpose shit again. Because this is output now after our all this stuff. Actually, what's going on here? What is going on here? Oh, yeah. Okay, so this converts him into something that's like 3 by height by width, and image PIL doesn't expect that, so we just have to do the same shit here. Which actually means, when we serve him now, we don't have to take our special path. We can just do the normal default behavior, I think, maybe. Who fucking knows? Okay. Now we're in like bullshit territory again. Because we still need to apply the normalize. Okay, so here we'll say, instead of trying to get clever here, we'll say less processed is equal to image 3 clone. Then we do the normalize here on the less processed image. And then we append less processed. And we probably need this conversion also on less processed. So the only thing that what are we doing here? We're basically only applying the resize and not the center crop, which is not helpful. There. No resize. Only normalize. Okay, does this give me something that fucking works? Refresh. Okay, there we go. Okay, so now we have something to start from that doesn't look like shit. This less processed thing does only a normalize on it, which we're fine with, and a conversion. Now we know that the center crop was okay, so it's very likely that the resize is our fucking problem. Right? I bet you if we just shove this guy on here now, less processed, shove the less processed on here, refresh. He does just like have that same fucked up look to him, right? This weird like banding and stuff. So let's see, update. Yeah. So it's probably it's so fucked. So we can probably, I bet that it's related to our interpolation mode. So like, what are our other options? Nearest exact, Lankzos. I've seen that word before. Let's just try it and look. Because bilinear, well, let's look up. What the fuck is bilinear interpolation? We should know what this means. Mathematically, it's not too complicated, if I remember correctly. Method for interpolating functions of two variables, x and y, using repeated linear interpolation. Usually applied to functions sampled on a 2D rectilinear grid. Oh, right. So, you have, like, if you have, like, 5 pixels, how do we say this? You have, like, a pixel that's stretching over, like, 1, 2, 3, 4 other pixels. The color of this pixel is going to be, like, some linear interpolation of this and this. So that's what the bilinear is. It's like they're interpolating on both x and y. And that's creating, like, some weird fucking artifacts. And what's Lank Zos? Resampling. They use a low-pass filter and smoothly interpolate. So something more intelligent. Let's hand wavy, maybe something different, maybe not more intelligent. Who fucking knows? And can we just go back here and refresh? It's not running, so can I just run this again? Oh, for the modes, only 3D, 4D, 5D input sensors supported. Got 4D. For the modes nearest, linear, bilinear, bicubic, trilinear, area, nearest exact. Okay, so it doesn't like Lanczos because of the shape of this guy, probably. Okay, let's just try nearest. Yeah, I like that. Just to see. Refresh. We are still seeing some of that bullshit banding. Like, why? What the fuck, man? That's really weird. Very, very weird. Maybe we try nearest exact. We just try them all. Fuck it. That's no good still. Interesting. Let's try resizing it to something larger. Just to see. Yeah, so if we go up, it doesn't seem to be, like, as fucked up. Okay. Interesting. So is there, like, an interpolation? Bicubic, box, hamming. Let's just try them all. Bicubic. This is a very scientific, very well thought out way of learning, is to just randomly click numbers until it... Still, like, what the fuck is that checker pattern? It'd be interesting to maybe see where it's coming from. Like, if we could look at, like, the same image and, like, correlate where it's checkering and where it's not checkering. Let's see. So maybe we can, just not do the resize here. Run this. Here we'll see the original and the fucked up one. Yes. So the fucked up one is like basically anywhere where we have this checker pattern. That's so funny. Ah. I think I get it. So he's trying to sample from this just like extremely high frequency signal here. This like tiny checkerboard, which I don't know if it's like very coming up very well on stream. But if it just like tries to sample between these, then depending on how it's sampling, it's like very likely to just always hit either a black or a white, which is probably what we're seeing here. So maybe we should slightly blur the image before doing that to fix the checker problem, which is kind of shitty, but that might actually like help us out a little bit. So we could say like image 3 equals transforms Gaussian blur, box blur, Gaussian blur, and we take in the image 3, and our kernel size is 3. And can we pad it? Do we have to pad it as well? Yeah, sure. Well, fuck it. We'll just try that. Kernel size list int. So maybe we need to do 3 by 3. And let's see if that looks less fucked up. Still fucked, but maybe we didn't blur it enough. That blur has done like fucking jack shit. Am I high? Image 3, Gaussian blur, image 3, 3 by 3. Can we just make it bigger? Is it because like the image is too big or something? Yeah, maybe we want like just like a fat box blur even. Do they have a box blur? Maybe not. Maybe we just do it a few times. I just want to like at least see the effect of it looking shit, and then we can like dial it back. Okay, there we go. Here we see the blur happen. It does. I think that there's probably a good chance that it's still. Oh, there we go. That looks a lot less shitty actually. Yeah. Sick. Okay, so let's hide this guy again so that we can look a little closer. All right. Those aren't the same picture. Okay, there we go. That looks a lot better. This is not the same. We're not looking at the same picture. What the fuck? There's a bug. Display none. So there's probably a bug with updating, but okay, there we go. There we go. Okay, I think that looks decent. That looks a lot better. And you could argue that, like, the checkering, maybe the neural network is, like, it's okay to leverage that. But it does. That looks pretty good. Yeah, okay. So I guess, what does that mean for us? It just means that we want to apply a blur to our generated ASCII image before doing anything, which is fine. That's fine. The like extent of the blur we might need to think about. But whatever. So here, just before we do any pre-processing, we do that blur. Then we don't have to do any of this shit anymore because everything else should just work fine. And then we do data append, pre-process. We've already done part of this. So we just do that part now. And ASCII images.append the ASCII image here. That's fine. Okay. Okay. So now we should be in a state still where we can look at the pre-processed image and visualize the other stuff. And I think everything's okay. I'm gonna have to be a little bit careful looking there. Yeah, like we've already fucked it up. I think maybe this. It's already got like the inversion of colors. Let me refresh. Because what have I done? Okay, here. We also fuck me. This is so annoying. This is annoying. So we do have to do like that like dimension switching for this case. Oy. And then does everything work? No, because he's not equal size, because somewhere I fucked something up. Here, I fucked up that. An extra append that I didn't want. Now does he run correctly? Looks okay. Refresh. Looks okay, but we're not getting the pre-processed image again, so let's see what the fuck is up with that. Dimension out of range, because I fucked something up. refresh. It is just a transpose issue. So what's going on here? Print image.shape. What am I looking at? What am I looking at? So here it's just height by width. I thought that I did the height width correction already here. Ah, I meant to do it here. I meant to do it down there. I just gave back the wrong image. There we go. There we go. Okay. Update. Okay, sweet. So now we have both the preprocessed one and this guy coming through okay. And we can have some form of confidence that it's working correctly. And so then if we go to train, we can have some confidence that the labels that we're spitting out are okay. So let's hide this visualizer behind a flag here. We'll say visualize is one of the options for our script. Parse args. So here we can just say visualize. Ah, image permute, a little less code than 2 transposes. Nice. That is something that I wanted to see before, so appreciate the tip. This is going to be a store true. So if we pass in the visualize thing, we will try to run the visualize, or otherwise we'll train. And then here we say if visualize. There we go. This guy is now got an option, the third thing that he doesn't give a fuck about. And so does this guy. And let's just try training again on, not on the sequential images from a video, but just on like those completely independent ones. Because I'm actually not really convinced anymore that the current neural network will learn correctly. Oops. Visualize is a required argument, which is just untrue. I don't want it to be required. I want it to be optional. So here we should see training happen. It would be nice to see like the correctness metric go down at some point. Why is it? Can you fucking stop spamming me with errors, please? Please? Oh my god, this usually like fixes itself. Oh, there we go. Oh, no. This usually like stops at some point. I don't know why. Okay, we'll just rm-r config am I open. This is working around a bug where if I train twice in a row, it just like doesn't fucking work anymore, but we'll just live with it. 5 seconds for get images? Weren't we down to like 300 milliseconds before? How? I thought we were at like 300 milliseconds. Is just the code that I just added that fucking bad? Where is the time come from? You might want to try median blur instead of Gaussian for the high frequency pattern. I think the kernel bias is a little stronger. Ah, I didn't know there was a median blur. What is that? Median blur. Digital filtering. Oh, so they just take the middle value in a section instead of doing like a weighted multiplication. I see. 3 pixel, 10 pixel. Yeah, and so then it's just defined by like what was the middle value in this big box. Maybe. I'll definitely keep it in mind because I don't think that this just like quadruple Gaussian blur is like necessarily the most reasonable, but I also don't think it really matters at the moment. So I'm not gonna go back right now, but I will keep it in mind for sure. Is something else taking a long time now? So in our image to text, are we really using the optimized version? We are. So something else must be causing the slowdown now. And it could be all of these clones that I've shoved around for like no fucking reason. Those could be tanking performance. So let's try that. Does that... there's the bug. rm-fr. Let's just see if that speeds up time significantly. or if we have to log performance again. Do we have 5 seconds? I feel like I'm high. Image A, image B, get ASCII image. Isn't like this all we changed? Labels append, data append. I guess maybe the Gaussian blur is taking a lot of time, but that doesn't really make sense to me either. Could be that these ASCII images, keeping track of them all is causing a performance problem. Oh my god. I guess I shouldn't just guess. I should just log the times again. Because, yeah, this is ridiculous. Unless... Was it this slow before? No, there's no way. Unless it was 30 milliseconds per image. Or 300 milliseconds per image. Fuck it, we'll log time again. Timer, log, time, get image. Ugh, what a pain in my ass, man. I just want to train some neural networks, man. With. Oh my god. I'm gonna lose my mind. I guess we are just extracting a lot of images per. And some of them are just arbitrarily long. Yeah, I guess... That seems fine. That seems passable. I was kind of hoping that we would be able to show some sort of progress on training today, but... I don't think I'm going to get much more free optimization. And I don't really want to try that hard. So I guess we'll see at the very least. This log here is like the accuracy. So let's maybe let it get through a little bit and see if it's like so unbearably slow that we don't get to a accuracy improvement. And we're not going to. It took like 100 iterations last time. Okay. Sorry, guys. Would have liked to get to the end of stream and show something like a little more impressive there, but I think that we did get a lot done today. We what did we do? We got like a pretty big like 20x speed up on our glyph rendering code, which is pretty sick. We got some we like generated a data loader that would load adjacent frames from a video. Pretty straightforward, but important for this task. We visualized the like pre-processed data and we found some bugs in there and kind of like smacked them out a little bit, which is pretty sick. And yeah, I think hopefully, we actually are seeing some correlation to that there, which is pretty sick. 62%. Let's give it a couple more iterations and maybe we will see it improve. Otherwise, thanks for watching. If you liked what you saw, I stream most days around like 1 or 2 o'clock Pacific time for 1 or 2 hours. If there's a YouTube channel linked in the Twitch description, if you don't want to watch live, and if you're watching on YouTube and you want to come by, say hi, give suggestions, whatever, there's a Twitch link in the YouTube description. There's a Discord link in the Twitch description as well if you want to chat about this shit while stream's not on. I also post like when I'm going to be going live in there with a little bit of a heads up if you want to catch the beginning of stream. Otherwise, I think that's it. It does seem like we are not learning fast enough here, so I'm going to have to do some more testing on this off stream. I probably won't stream tomorrow, but I'll probably be back Tuesday. So, thanks for watching, guys. Catch you on the next one. Bye!